All right, 2019, number 3. We're going to have a continuous function f, which is pictured here in the graph. It's defined on a closed interval from -6 to 5. We only get to see from -2 to 5. The figure shows the portion of the graph of f consisting of two line segments and a quarter-inch circle centered at the point 5, 3, which would be the center of that circle. It is known that the point 3, 3 minus radical 5 is on the graph of f, so that point there is 3, 3 minus radical 5. All right, in part A, if the integral from -6 to 5 of f of x dx is 7, find the value of the integral from -6 to -2, the part you can't see. So we just use one of the properties for integrals where the integral from -6 to -2 plus the integral from -2 to 5 would equal all the way from -6 to 5. So we're trying to find the integral from -6 to -2, but we know, or actually we can figure out the integral from -2 to 5. And that's because we can get the area of this triangle as a half. This triangle down here is going to be a half, so those are going to cancel out when you do an integral, positive half and negative a half. Then this here, we have to figure out, well, we got to be sure where this is crossing the x-axis to know this length right here. So the slope of this is up 4 over 2, so the slope is 2. Y-intercept is -1, so this curve is y equals 2x minus 1, which means the x-intercept is a half. So that means 1/2 times 1, and half of that means that area is a fourth. This area is 9/4. And lastly, we have to find this blue area below the quarter circle. In order to do that, we will take this square, which is 9 square units, subtract off the fourth of the circle, and we'll be left with the blue area. So it's going to be 9 minus a fourth of pi times 3 squared, which is the radius of the circle. So that's 9 minus 9 pi over 4. So then the integral from -2 all the way to 5 will be the 1/2 minus a half, and then a -1/4 plus 9/4, and then plus this blue area, 9 minus 9/4 pi, or 9 pi over 4. The 1/2s cancel. 8. This will be 8/4, which is 2, plus 9 is 11, so it's 11 minus 9 pi over 4, which we replace the integral from -2 to 5 of f of x dx with that. So to solve for this integral, -6 to 2, -6 to -2, subtract 11 and add the 9 pi over 4, we end up with this integral from -6 to -2 of f of x dx equaling -4 plus 9 pi over 4. And that's the answer to part A. Let's take a look now at part B. They want us to evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 dx. So we will take this integral. I'm going to separate it into two integrals and pull the 2 out front, so it's 2 times the integral from 3 to 5 of f prime of x dx, and then plus the integral from 3 to 5 of 4 dx. And for the first part, we'll use the fundamental theorem of calculus. So it'll be 2 times antiderivative of f prime is f, so it'll be f of the upper bound 5 minus f of the lower bound 3, all multiplied by 2. And the antiderivative of 4 is 4x, and then so that's just going to be 4 times 5 minus 4 times 3, and or it's a constant, so it's just the constant times the difference in minus the upper bound minus the lower bound. So anyway, we get 2 times f of 5, which we just get from the curve is 0, and f of 3 they gave us is 3 minus radical 5, and then 5 minus 3 is 2 times 4 is 8. So you end up with 2 times -3, and then minus the negative is plus radical 5. That gives you negative 6. And then the plus 8 gives me 2. And then the 2 times radical 5.